Good morning, everyone. So what we have today is an idea that many of you in this room, especially if you're working in product security teams, would have thought of at some point in time or the other. We'll be talking about vulnerabilities, not in the code, but in the way you ship the code. So some of these bugs can be so simple that they make you wonder about the SDL and the security validation that goes on behind them. And on the other hand, some of them can be so complex that they may even baffle or startle your security, even your best hardened security developer. Right, so we'll take a few examples today, what kind of security misconfigurations that we have seen when you're working with different product teams. And we'll also propose our solution, an idea that we have in catching these kind of security problems, these kind of configuration problems really, and how we want to make the world a better place that way. We had planned for a demo, but unfortunately we don't have the GoPro today here. So we'll be showing you how our application or how our tool really works through screenshots. But if anyone of you is really interested, just come talk to us after our presentation. We've got a couple of devices here with us today, and we'll be able to give you a demo of what we have. Right? So before we get into the details, a really quick introduction. My name is Sumant. I spent about a decade in the security industry today, and I work for Intel. I manage some of the Android security assessment efforts there. And I also manage some of the product security teams that develop new security solutions on top of Android. And before my job at Intel, I worked for Palm and for Sun Microsystems, doing PCERT, pen testing, security stuff, basically. And my co-presenter today is Akhil.
Yeah, so I joined Intel last year, and I used to work with Sumant in the security assessment team. Now I'm working as a research engineer in Xerox Research. So my major interests are data mining, machine learning, and databases. And yeah, this work was done during my stay at Intel.
Thanks. Okay, so let's get down to business. Let's talk about the easy bugs first. Right, so think about a scenario where you have a development team, someone who's writing a new feature on Android, and think about a situation where they want to make several applications, let's say 2 applications, access the same file on the Android file system. Maybe read the file, maybe write to the file for whatever reason. And believe me, this happens. And there can be many ways to really solve this from a security point of view. The easiest solution would be to just do a chmod 666 or a 777, and that works great. Right? And think about a similar example from a process point of view. Let's say you are, again, writing an application, writing a new service or an app, and you want to use more privileges than what your standard Android service or third-party service can have. What you do in that case, you just make your application a system app or run your service with the system user ID on Android, and then boom, everything works perfectly well. But you need to remember that the system user ID is sort of a pseudo super user. It has a lot of privileges. So if things can go wrong in your implementation, if you have a bug, then you're really releasing a conduit there for privilege escalation in a system, and that can get really nasty. Right? These are simple bugs. These are low-hanging fruits. They happen every day, every other day when you're working with large teams working in Android on a development platform. And things can get a bit more complicated, right? Set UID files. These are kind of my favorite. These are hard to get right. And you learn in Security 101 that you've got to be really careful in the way you set the bit, the way you understand the real user ID, the effective user ID, when you need to drop the privileges, when you need to gain them, and so on. So these can be complicated. And if you look at the Android security best practices document, it has a bunch of should nots and must nots in bold in this UID section for a really good reason. And also the Android CDS test suite will just reject if you set the bit on some of these flags, also for a good reason. All right. And things can get even darker. So people know that set UID files are bad, they're evil, you shouldn't use them if you don't know what you're doing, and so on. So an alternative, is a better, more fine-grained alternative is to use the POSIX file capabilities. These are even harder to understand sometimes. You need to know how you configure them, how you set them, how you inherit them, and so on. And what's worse is that sometimes it gives you a sense of complacency that you're using a secure alternative. But some of these capabilities are pretty complex, right? So if you look at the list of caps that POSIX allows you to do, there are some of them that have a really long list of attributes that give your application or your executable the kind of privileges that almost makes them setuid, right? So if you've configured them well, if you're using them well, if you know when to drop the privileges and use them effectively, then that is great. But then if you don't do it, it's kind of setuid wolf in sheep's clothing again. And believe me, these are real world problems, right? So the first headline that you see up there, it's happened a couple of years ago. Very simple bug. The devx in osmem device file basically had word writable permissions on some of the devices. That gives your average Joe Schmoo application, your Facebook, your Angry Birds, complete access to the device physical memory. So you'd wonder how that even got in there, but that was on production phones, and that was disclosed publicly. And the capabilities, like I said, these are much harder, but they're not without problems either. The second headline, again, a true story. This happened several years ago, but improper use of the capabilities actually led to root compromise on several Linux machines. So the statement there, when is a setuid program not a setuid program, that's actually from Theodore So from his keynote at the Linux Security Summit last year. So that was a really interesting talk. So that led, that is kind of motivation for us to think about what kind of problems can come out of setuid and the file capabilities. All right, so far so good. So we've been talking about vulnerabilities that mostly result from a particular feature. It's kind of contained or isolated to one feature that you're developing, right? So maybe you have infinite time and resources and money. You can have months of penetration testing done, and maybe catch these kind of chmod issues, process permissions, setuids, capabilities, and what have you. But we've also seen cases where a team, probably it's not very security aware, can introduce vulnerabilities in things that are completely unrelated to their code. So on the IA32 architecture, on the Intel architecture with 32-bit addressing, you have the ability to run 64-bit programs if you enable PAE, the physical address extensions, right? So let's say we have a team that's working on a 32-bit platform, and for some reason, maybe they are messing with 32-bit and 64-bit code together. Things are not working well. They need to debug something, and they turn off PAE, the physical address extensions, and everything works well. Sometimes months can roll before you even realize what is going wrong, and usually you get this pushback from the development team saying, everything is working well, why do you want to change anything? An interesting case here is that on the x86 architecture, the non-executable feature, the NX bit, is actually set to 1 in the 63rd bit in the page table entry. So you see what I did there? So if you're turning off PAE, you do not have a 63rd bit anymore in the page table entry, which means that you've turned off NX, and you've suddenly left the platform with a huge security hole. True stories again. All right. So what I'm trying to say here is that if you look at these examples, these are not bugs in your implementation. These are not your average buffer overflows, null pointer dereferences. So these are the things. These are cases where you're shipping something, you're configuring something, and then you're introducing vulnerabilities. Some of them really simple. Things can go bad. And what we feel is that these classes of vulnerabilities should be caught quickly and efficiently. And for that, we are proposing a tool, an idea really at this point, called Iron Crow. And this is what we have. I'm going to turn it over to Akhil to explain what the tool can do today.
So, hello everyone. So, the idea behind, as Sumant has already mentioned, is that these are the blue ones that you see.
I think you're mute.
What? Okay. Sorry. Yeah. So the idea behind this is that you can see the blue bubbles here, which actually point about the features that Sumant was mentioning. So I'll start with the NX bit, which is a very simple thing. So this bit actually tries to, it's a technology used in the CPU to mark different areas of memory as either to store code or data. So, and in that case, an operating system can actually try to mark these regions which contain just the data to be non-executable. So the idea here is that It actually tries to prevent the classical buffer overflow vulnerabilities that could actually occur. And here we actually implement a check here at 2 levels. So the first level is that we try to check the proc to see that whether the operating system has the capability to enable NX or not. And at the second level, what we do is that we actually try to execute code from the data pages. And we receive a memory access violation, thus stating that we have an check there. Moving to the second bubble where we have this mmap min adder. So this is a kernel tunable which actually defines the minimum virtual address space where a program could mmap to. So the interesting thing here is that if this is actually used to avoid the kernel level null pointer dereference attacks that could be there. So the idea here is that if the mmap min adder value is not set to a proper limit, so what could happen is that a hacker or a malicious user can strategically place a code at the address pointing to null, and then it could actually lead to system crashes or even privilege escalation, or maybe unintended code execution. Then moving to this capabilities part, which is, we think, I guess, is the most interesting part of our tool, because these really are, as I feel, these people don't really know about how to configure them, how to use them, how they are inherited and stuff. And these were actually implemented, these were actually placed to see that you just don't use setuid root programs. You say that I will define, just to make sure the privilege of least privileges. So what we do here is that you have these different kind of capabilities like cap setuid, cap DAC override, cap sysadmin. So these capabilities, actually, if you take a union of all these capabilities, you become root. So the interesting thing here is that you have these different capabilities and people don't know how to use it. So there should be a tool which is able to scan the whole file system and to see what kind of capabilities are enabled for these files. So the interesting thing is here that if you have kept setuid capability associated with your file, then it can perform any kind of setuid changes. So it can map to any arbitrary setuids. Then instead, and moving to cap DAC override, what could happen is that, so this can actually bypass the read, write, and execute permission checks, and you can probably write to a place which is not, where you're not authorized to do that. Moving forward, I mentioned something about the capability called cap sysadmin. What could happen here is that they have a long list of things what a file, if it has that capability, could do. So actually, capabilities are set as the security extended attribute with a file. So what could happen is that if a file has this cap sysadmin capability, it could actually change this extended attribute as well. So the interesting thing that we could see here is that finally, one can actually gain any capability if it has the cap sysadmin capability. So moving ahead, our tool also does this kind of the other checks on the left, where we check for world writable files, which can actually uncover vulnerabilities like what happened with the Samsung Exynos vulnerability. Then you have check for setuid files. You also have check for privileged processes. So here we mean that you should have a whitelist to see which all processes are actually allowed to execute as root or system. So, and we also have plans to add these other checks which are there in yellow, but probably as a second version of this tool, where we want to check for compile time flags. Again, going by what Android recommends, we have the recommendation says that you should have a level of you should have a level of source fortification with the code or fstack protector. So these flags should be enabled when you compile this code. And then we also want to check for certain networking related checks. So what do we want here is that we need a device, which is probably an engineering version or a development build. And then the other thing is that you want to configure your whitelist intelligently. So the whitelist would be the one which actually won't raise a flag if it exists on any of these features that we talked about. So a whitelist could be configured also by an OEM or a vendor, just to see that which things are actually allowed and which are not. And the third thing is that we also have flexibility that you can either run it as an app or maybe an automated tool integrated towards the automated security assessment that people do. So we're sorry again that we don't have a demo, but I'll probably point out the features from this slide. So we check for the NX bit, if it's enabled or not. We check for the mmap min error value, if it's set to a proper limit. And then the colored ones are here actually the things we are talking about. So these can actually change with the whitelist. So we have actually implemented the whitelist for world writable files here for this particular snapshot. And you see that there are certain world writable files which are allowed and which are not allowed. So with the demo, you can actually see we also list the files which are there. So these are probably the world writable files, and we have added this to an ignore list as of now. And apart from that, again, we have checks for all these setuid files, capabilities, processes running as root or system. And then we see that for the file capabilities, the interesting thing is that Android allows the run as utility to have these capabilities. And thus, again, this could be a part of the whitelist. So I'll handle over to Sumant for the next slides.
Thanks.
Yeah.
So again, if you're interested in seeing this tool with your own eyes, we have got a couple of devices here, so feel free to just come and talk to us after the presentation. So our proposal really is that Android is a complex piece of machinery. So you have way too many entities. You have the Linux kernel, you have the AOSP, you have the BSP vendors like Intel, you have OEMs and the MNOs before you actually give the device in the hands of a consumer. And each of these guys add more and more code on top of what they get. And in the Android space, everyone talks about TTM, the time to market. So no one really has the time, the months or even weeks to do a thorough penetration testing or code reviews or security configuration reviews over and over again, and it's just wasteful, right? So what we feel is that a tool such as IronCrow or a framework such as IronCrow should be made an inevitable tool. It should be made as part of your gating criteria or your exit criteria when you're saying that your platform is ready or it's production quality and be shipped off to an OEM. So we think that something like this would be very useful to OEMs and MNOs and BSP vendors. And if you really think about it, many of these bugs are kind of endemic to Linux, not necessarily to Android, although we have customized this to Android. So we've seen some interest in people who work on Linux, develop solutions on top of Linux or even distributions that add their own value-added applications on top of the kernel. Of course, needless to say, security assessment teams should also be interested in this, in using this and making sure that the platform is secure and stuff. So that's what we have. And we are sort of at pre-beta quality today. So we are also working in parallel in expanding this tool. And we're going to make this publicly available soon. If you are interested, do drop us a note. Our emails are on the next slide, and we'll be happy to get back to you on that. So thanks again. That's our email addresses. And I apologize for not having the GoPro today, but we'll be happy to show you the demo if you need me. Thank you. And if there are any questions, I'm happy to take them. Yes.
Do you plan in the future to open the source?
I'm sorry, can you repeat that?
Do you plan to open the source of your talk?
Yes, we are working on that. If not, thank you very much. Thanks again.